This question is going to be quite a feast because there's so many interesting aspects to it. And so the first thing is that we've got a sketch of gx, which is 2 over 5 to the power of x. And we've got p, which is the intersection of gx with the inverse. And so out of interest, that will mean that p's value will also be 0.59, because it will be running through, if they're inverses, it will be running through the line y equals x. And so the point of intersection will be on the line where y equals x. So that's just a quick little trick to get p out the way. So there's that answer done. Otherwise, I could have also just said, oh, I'm missing a letter in graphs. What do I do when I'm missing a letter? I just sub in a point. So I could sub this in for y and p in for x. And then you would have said, oh, I'm needing a power. So you could jump into logs. So I might just do that on the side to show you what I mean. And b is minus 2q. That's on gx. And so let's get q for starters. So when I'm missing a letter, I sub in a point. So y equals 2 over 5 to the x. And minus 2 is the x value. And q is the y value, and if I put that in, a minus just flips the fraction, and then I will square the 5 that's now on the top, and I'll square the 2 that's on the bottom. So that's just how to get the q value and the p value. And then what I was explaining about the p, just to take it from different angles, you could do this just for practice. So I'm missing a letter, same as what I've just done with q. So what I would do when I'm missing a letter, I sub in a point. So p would go up here for x. So it would be 0.59 equals 2/5 p. How do I get a power? If I need a power, I use logs. The base of the exponent is the base of the log, and the other number is the other number, and that would give you your p value. So that's just if you wanted to use logs, but this was hopefully an interesting way to think about the point of intersection. Then if I needed this y-intercept, I just let x be 0, and anything to 0 is 1. So if I want to sketch the inverse graph, which they're not asking, but I just want to do it for your help. At the moment, we've got an asymptote here at 0. So if I wanted to sketch the inverse graph, then what it would look like is the y-intercept is 1, so now the x-intercept would be 1. The point of intersection would obviously just be the same, this 0.59, 0.59. And if the y-asymptote is 0, now the x-asymptote is 0. And so if I sketch the graph for your reference, it would look something like that. Find the equation. How do I find the equation of the inverse? I take the original, and like any inverse graph, if this is my original, step 1 is to swap the x and the y. And step 2 is to get y by itself. When I need the power, I use logs. The base of the exponent is the base of the log, and it never looks the same, so this must be x. So here's your equation of your inverse. In another video I made, if you're finding the domain of the inverse, that will just be the same as working out the range of the original. And so without having had a sketch, you could have just said, if you know that trick, oh, okay, so I just need the range of this original black one, which is y is bigger than 0. And so what would the domain of the inverse be? It will just be x is bigger than 0. So that's a cool trick with domain and range, but you can watch the other video I made of that. Visually, if you want to understand what the domain of the inverse is, it's the red graph, and the domain is the x value. So you can see the graph is always to the right of 0, but never equal to 0. So that's how we got that. Describe the translation from g to k if kx equals all of this mumbo jumbo. And what the main thing is that you want to notice is that the original the whole time has been 2 over 5 everywhere, but now it's 5 over 2. And so that's the biggest trick they're saying. Did you notice that? Because if you did, you can just flip a fraction if you take out a power of -1. I don't know if you knew that. Fractions flip when they're to a power of -1. And so let me just do that little trick for starters, because then I'll have it in the kind of correct order. It will be 2 over 5 to the positive x minus 2. How has that translated from the original fx? Well, it was just 2 over 5 to the x, and now it's x minus 2. I like to think of this as a bracket, and so you can think to yourself, what answer comes out of this bracket? It would be positive 2, which means it's gone 2 to the right, and then the minus 5 over 2 at the end is simply the fact that it's shifted down. And so it's literally just shifted 5 over 2 down. So that's the translation. 2 right, 5 over 2 down. And then in the last question, find the values of x for which the original black graph is below the inverse. So in the beginning, the black graph, there is no inverse graph happening in this quadrant. So I'm only really interested in the first quadrant. Where's the black graph below the red graph, the inverse? It's here. And then what happens after here? It is above. So all I'm interested in is just that tiny, tiny little section here. How do I write that answer as an x answer? Well, x is 0 here, and it goes up until the point of intersection, which was 0.59. I should underline both because it says or equal to, but I never underline when there's an asymptote because it cannot equal 0. And so that actually ends up being your ultimate answer. Just x is somewhere between 0 and 0.59. I hope that you found that video helpful. If you did, please like it, subscribe to our channel, and share it with your friends.